Randall for so many years now. We met at reInvent when Randall used to work at AWS. We had a great time at that time. And then I've been meeting Randall every year at reInvent. He always does some kind of podcasting and whatnot, Twitch, streaming, great talk. He's a great person to talk with. And Randall kindly accepted my invitation to come talk at our conference. And he has experience of working at AWS for a long time and as a developer advocate. And now he works as a partner of AWS. So he's going to talk about how to make use of the global reach of AWS. Thank you for taking the time. Randall, come on, and let's hear you talk.
So, hello everybody. First of all, can we just give a round of applause to John and all of the volunteers and all the people who... I love AWS Community Day. I love meeting all of you wonderful people who are building fascinating things in AWS and learning about all the great stuff that you're doing. And I just think this is a fantastic way of celebrating all of the cool stuff that people build on the cloud. And thanks for setting it up. So I wanted to talk today about some of the things that we might have missed during the COVID years. So there have been quite a few changes within AWS, and it's often difficult to understand the change, the scale, and the things that happen. If you're particularly familiar with AWS, this talk might seem a little basic for you. That said, I do have some nice little deep dives that you could be interested in. But this is more of an overview talk, and we're going to go across a bunch of different topics, and then at the end I'm going to make a prediction that everyone's going to disagree with me on, but that's okay. That's what we're here for, is to have some nice discussion. So, like I said, we might have missed a few things during COVID. And I think when we think about the global architecture, oh yes, perfect.
That works.
Thank you, thank you. You're saving me here. Woohoo! So when we think about infrastructure, right, we have a couple layers of consideration. You know, at the bottom layer, you have your physical infrastructure. These are the switches, the racks, the power supply, the generators, like all the stuff that you need, the fiber through the ground. This is the stuff that AWS makes us hopefully not care too much about, but occasionally we need to be aware of it still. Just some of the nuances around it, you know, the availability concerns and stuff like that. But generally, physical infrastructure in the cloud, we just don't care anymore. Then you have the networking. This is a shared responsibility between you and AWS. The physical infrastructure of the networking is taken care of, but a lot of the routing and the choices that you would make from a VPN perspective or from a direct connect perspective, all of these things, those are still left up to you. Some of the security considerations are left up to you. Then we have the data layer. Data is frankly the hardest problem to solve. Whether you're on-prem or in the cloud, it's very difficult to do OLTP at scale because you have, you know, all these different data structures that all of these database engineers have been working on for the last, 30 years, and they're all stealing from the 1984 Stonebreaker paper, which was ahead of its time and massive and wonderful, and Postgres rocks, just throwing that out there. And then, data I don't think is a fully solved problem within AWS or frankly any cloud provider. It's just difficult to do. There's laws of physics that prevent us from doing the kind of real-time stuff that we would love to have, like a global master-master replication situation. And then we have compute. And compute at this point is pretty darn easy. Like this, I can't imagine it getting much easier than it already is. Like compute is solved. From my point of view, infrastructure-wise, compute is just a solved problem. Your infrastructure can be ephemeral, it can live wherever in the world you want it to live, and it can help get your compute-intensive tasks to your end consumers as quickly as possible. And then you have your application code. And this is not solved yet because we're all software engineers and we're all terrible coders. At least I am. But I think we've all experienced, oh yeah, like it compiled on the first try and then worked fine in dev. ops problem now. You know, like application code is something that will be with us until artificial intelligence takes over and replaces all of us, and we can live in, you know, a post-monetary economy like the Star Trek days, right? And then we'll just spend all of our time on the beach. I don't know. They're really interesting things that happen in application code. So often you'll think about solving certain availability issues at the networking layer, right? So you can use DNS as a mechanism for failover or for high availability. But often that's not enough anymore because the failure modes that happen are not ever a clean cut. It's never like, oh, this region just disappeared, this network partition happened. The way that these failures happen is they often manifest in terms of, you know, brownouts or rolling kind of failures that don't, you know, immediately seem clear. And so you have to build a little bit of orchestration code on top of your default health checks and auto-scaling groups and all of this other stuff. You need sort of a break glass like, hey, it may not show in CloudWatch yet, but we know this stuff is down, let's change it. That's the kind of orchestration layer that you need when you're operating at a sufficient scale. And one of the things that I thought was very interesting was during the, we're not supposed to say outage, so we're going to say during the period of decreased availability that occurred in US East 1 in December 17th, that affected a small portion of AWS customers who use US East 1, that you'll remember that DynamoDB had a pretty significant sort of lack of ability to read. Now, if you were using global tables, the replication actually kept working behind the scenes. So if you were using a global table in like US East 1 and US East 2, that replication never stopped working. It's just that your functions, your containers or your lambdas, they couldn't talk to Dynamo. So what if your application code was aware of if it had a priority queue in terms of latency for which regions it could talk to? And there's certain SDKs that are built on top of the Java SDK for AWS, for instance. Like you can now put in that priority queue of different regions and endpoints that you want to talk to. You can do similar things with Boto 3, but you have to go on GitHub and look at a gist that I wrote like 4 years ago. But I mean, the application code side of things is something that we're still going to innovate on for a period of time. And then we get into this side, the people. As Adrian Cockcroft is very fond of saying, it doesn't matter how much you invest in your infrastructure if you don't also invest in your people. So if you don't try to get the people within your organization trained up and have them actually practice failovers, have them practice disasters, and have, you know, why do we practice fire drills, right? Why do these corporations mandate fire drills besides the insurance companies telling them they have to? It's because when you rehearse this stuff, when it actually happens, hopefully, you know, you do the right thing. You get out of the way, you get out of the building, and you do all the right stuff. So if you don't rehearse these sorts of availability failures or constraints from a people level, like just take a day once a quarter and say, this is break everything day. And we're gonna imagine what happens if like Slack goes down. We're gonna imagine what happens if we have no means of communication because like Verizon has shut down. Like how do we keep the business running? And if you're selling pictures of cats on the internet, it probably doesn't matter that much. But if you're in a healthcare scenario where people's lives depend on what sort of software you're running, yeah, like it's important to rehearse these things, and you'd be surprised how many people don't. So those are the layers of consideration that we have. And I'm going to dive into each of them individually and how that pertains to AWS. So if you look here, this is a little bit of an older video, but this shows a lot of the regions within AWS, and then we're going to zoom in into a fully scaled out availability zone, like US East 1. And if we look, you'll see this highly redundant network. I think there's something like 533 unique fiber paths in this one availability zone. And this terminology often gets confused because the term availability zone has been around for a long time. If you've been like a NOC, you've seen how these things have evolved. And what it means to other cloud providers or to other systems is very different than what it means to AWS. An availability zone within AWS is typically multiple physical data centers. And James Hamilton spoke about this a couple years ago at reInvent, and he said, oh, you know, we're going to build like 100 megawatt facilities because they measure them in terms of power. And we're not going to go bigger. And why wouldn't you go bigger? Because other data centers, they've gone much bigger than 100 megawatt. So why wouldn't you go bigger? And a lot of that comes down to blast radius, because imagine you lose one of these data centers and you've got to now rehome all of the workloads that were in that one thing into another data center. So by focusing on that kind of 100 megawatt-ish scale, AWS is able to provision multiple data centers, get new real estate, get new stuff as they need to. So I thought this is interesting. If anyone's ever been kind of a fiber or network engineer, does the like 533 unique fiber paths that you have to manage, does that not give you chest pain? Because it does. I mean, just thinking about it makes me uncomfortable. So it's pretty massive. And most of these regions, they'll have some transit centers, they'll have their couple of AZs, and then they'll have each AZ is a couple of different data centers. And there are different things that you can do within AWS. There's something called placement groups. People often think that placement groups are only for keeping workloads nearby, but you can also do placement groups to keep workloads separated. So placement groups don't just keep things, your only option is not just to put them as close together latency-wise, like on the same rack if you want. It's also to keep them as far apart as possible for failure isolation. And people always forget that point. It's a very powerful tool, and I don't think they charge anything for it. So use it more. This is an interesting example. So when you work within physical infrastructure, you basically have to go, especially at the scale that AWS that we looked at earlier. So on the right-hand side, you see a standard 2-inch conduit, and I think it's got something like 3,500 some fiber pairs inside of it, which again gives me chest pain. What they did is they spun up like an applied photonics lab. I think part of it's in Sunnyvale and part of it's up in Seattle. And they hired a bunch of really, really smart PhD people who all wear eye patches because they work with lasers all day. And they gave them some safety glasses, and they were like, how do we make fiber better? And the result was the same 2-inch conduit can now hold something like 6,900 fiber pairs. That number's not quite right, but it's something around there. So by innovating at every layer of the stack and trying to find margin at every layer of the stack, they can more than double their network capacity. And as a consumer of AWS, we never even care or notice about this. Has anyone seen the Trainium instances? So these allow you to do 800 gigabit per second networking. 800 gigabit per second networking. Not single flow, but that's pretty massive, right? Like, I could host so much Minecraft on that. Like, so, and we can talk more about like DWDM and all the fun things there, but I think it's better to go a little bit further. Oh, I've got one more fiber slide. So this is a picture I took at reInvent last year. So these are the different kinds of fiber that are being used. There's also, AWS invests in their own, takes part ownership of these transatlantic or transpacific or transoceanic cables. So, and then hedge funds buy them up and resell them. But anyway, you have to invest at this global scale to be able to deliver the stuff that AWS is delivering these days. So what does it look like, physical infrastructure-wise? Like, where do we stand? So we've got 27 launched regions, and I think 7 more on the way. It's a little hard to confirm. AWS PR, I don't work for them anymore, so they can't tell me that I was wrong here. But 87 availability zones, so you could call it 87 and a half maybe. You've got 17 local zones, which I'll talk more about later. I think local zones are a sleeper hit. Anybody using local zones? All right. Anybody got latency sensitive workloads? Everyone who raised their hand should give a little look-see at the local zone stuff, and I'll talk about that later. But 28 Wavelink Zones, a bunch of direct connect locations, and something that people often forget. So now we're talking about CloudFront, right? 410 edge locations and 13 regional edge caches, which serve 90 plus the largest population cities in the world and 47 countries. And there's something that people often forget about in terms of the global internet, and it's that in order to get the best throughput possible, you have to have the fewest hops possible, because every time you're making a hop, you're shifting bits into a piece of hardware that's got to do something. It's got to encapsulate a packet. It's got to figure out where the next step is. It's got to pop some headers off. It's got to do some traffic shaping. All manner of different things, right? So by strategically peering with virtually every telecom provider, AWS is able to deliver a lot of latency that other people are not able to. Now, peering is a very dark art. So I have this funny story of how one company that, I'm not going to say their name, was able to get level 3 to peer with them. And it involved them baking a cake, putting frosting on it that said what their ASN was, and then mailing that to the level 3 office and having them open the cake and say, please peer with us. So, and just, sometimes it's a monetary relationship. It's just, there's a whole manner of things that go into creating these peers. I spelled peers wrong, I should fix that. Just pretend that's an E. And I think we often forget about what it takes to deliver this sort of stuff. So then, all of this is provided by a fully redundant 100 gigabit parallel fiber network that circles the globe and links with 10K other networks. I think that's just a very cool point that we often skip. This is what it all looks like. And so now we've talked a little bit about the physical infrastructure. We can talk about some of the things that are happening in networking. So has anybody noticed lately, every other announcement from AWS seems to have the word IPv6 in it? So there's this big, big push from AWS to create IPv6 and make it your de facto method. And a lot of that is enabled much more easily than it was previously. And if there are any AWS people in the room, can you +1 my product feature request for API gateway getting IPv6? Just thanks. All right. This is making networking a lot simpler to deal with. We're not having to deal with a bunch of natting anymore, and we can basically provision whatever we need. And I expect this trend to continue. So as you look at modernizing your infrastructure over the next, say, year, not investing and figuring out your IPv6 strategy is sleeping a little too hard. Like, this is something that you've got to be prepared for. Direct Connect Sitelink launched. I think it's generally available now. And this is letting you leverage AWS's own global backbone without having to go to any individual region. So you can use AWS's infrastructure. Like I said, it's this private network that they've built around the world. And you never have to touch a single region, but you can go and to connect directly from your office to the branch office in Paris or the one in Tokyo. This also simplifies the networking because you can start to share one kind of global map. And the ideal version of that, right, is going to be CloudWAN. I think CloudWAN is such a great kind of hit. The thing that sets it apart, it's almost like we're going backwards. Does everyone remember EC2 Classic, like before VPCs? Like, it was so beautiful. The world was so young, and we didn't have to worry about anything. Like, we could just give me an IP, and then all the other IPs could talk to all the other IPs depending on what you set your security group to. Wasn't that a nice time? And then we had to put NATs, and we had to put transit gateways and all this other stuff. And it just, well, transit gateways are amazing. Let me not diss them. But we had to do all of this stuff to make the networking work, and it was a pain. So I really like that CloudWAN allows you to have this flat global network, and it makes working with your whole sort of global infrastructure setup much easier than it used to be. There's some weirdness still between a CloudWAN gateway and a transit gateway. At reInvent, they said that they were going to solve this and make them work very seamlessly together. There's certain limitations to be aware of within the transit gateway side. Like, if you're using jumbo frames, like, it'll just silently drop them. So, like, if they go over a certain size, so there's certain gotchas still. But generally, this is a very big win and a huge success for AWS. So transit gateway is pretty interesting. How many people use transit gateway right now? Again, sleeper hit. People got to gateway load balancer. Anybody use that? Okay. Gateway load balancer, if you look up Aidan Steele, he created something called the upside down internet. It uses a gateway load balancer to transform with a custom SSL cert all of the HTTPS traffic that's coming in. It flips all the images and all of the text upside down, and it uses a Lambda function to do that. Like, gateway load balancer is one of the most powerful services within AWS for transforming and doing whatever you want with your traffic. And you can build your own network appliances on top of it. It's incredibly powerful. So when we get into intra-region peering, like that seems quite easy, right? Like we could already do intra-region peering. Like why does this matter? If you've ever bought a company and had to incorporate them into your own business, this saves you a lot of time and effort. Because instead of having to go and figure out how you're going to get all of their infrastructure moved into your own infrastructure, it's just like, hey, you got a transit gateway? We got a transit gateway. Cool, here's some routing rules. And now we all share the same infrastructure without having to think too much about it. So there's a lot of very powerful stuff that's happening within transit gateway, and this intra-region peering is going to save a lot of time for people. This preview is wrong. I think this is now generally available. So private 5G, what happens is AWS will ship you some cell radio units, a couple servers, and then the software for provisioning this. If you run a hospital, if you run like a manufacturing system, like this can be a great solution for you. There's a lot of stuff that's going to happen in this realm that makes spinning up new physical infrastructure easier, but I've been very interested in this. All right, and now we get into the fun part, because this one's solved, right? This is the easy side of things. Just a quick refresher, because I realize not everyone remembers. In terms of the setup of how you parse these instance types, right? You have your instance family on one side, and you have things like compute, or you have RAM, or you have M, which is general purpose, or you have Z, which is high frequency. I mean, you have or X, which are like really big instances. That just tells you like what kind of instance it is. The next one is the generation. Generation-wise, they typically always get cheaper in terms of price performance. That's not 100% true. There are exceptions to that, but you're typically getting better price performance every time you go up a generation. And then you have capabilities. So capabilities, A is AMD, G is Graviton, I is Intel. Is anyone else surprised at like the silicon innovation that's happened? Like Graviton 3 is incredible, Graviton 2 is incredible, but also it's just, we now have to specify that certain instances use Intel, like use regular old x86, because by default, some of these newer instances are Graviton-based. I think that's pretty powerful. It used to be, AWS would buy processors from Intel by weight. Like you don't order a certain SKU. You're like, just ship us 2 tons of processors. And then you have things like NetIn, which are network optimization, B, block storage optimization, E, extra memory, and these can be mixed and matched and combined. And then you have the size, and we have instances now that go all the way up to like 24x large, as long as you're blindly swiping your credit card. And then we have Outpost, and Outpost is a way for you to get a rack. It's a way for you to get even smaller than a rack, kind of in your own data center, off to the races, good fun. And you can run a significant set of software on Outpost now. So you can run EKS, you can run ECS, you can even run certain kind of databases on there. It's getting very, very powerful, and I expect that trend to continue. Outpost, expanded to a couple of different places now. And we've seen the evolution of this. AWS still hasn't comped me, AWS still hasn't comped me a free rack for my home lab, but one day, looking at you, AWS, one day, I want one. These will let you, like I said, run EC2, ECS, edge services like IoT Greengrass. And the most important part about this is that you get your same control plane. The same API calls that you use to spin up an EC2 instance are the ones that you use to spin up that same EC2 instance in an Outpost. That is quite powerful. Now, these new kind of single rack ones are pretty interesting from a latency perspective, because let's say you have some on-prem workloads or some place that AWS doesn't have a local zone, they don't have a good geographic footprint, which is vanishingly small now, but let's say that you're there and you need to get some sort of data and workload out there. Well, you can provision an Outpost and get it into your colo or get it to your office, and you can say, okay, cool, I'm gonna off to the races. The 2 new form factors here, you'll notice there's the 1U. That one runs Graviton 2 ARM processors. And then the 2RU one can run x86. And why is one big and one small? Well, ARM is quite efficient and doesn't need as much power and doesn't need as much cooling. And then you have your Intel, which is like, let's spend as much energy as we can as quickly as we can. Sorry, I know Intel's here. I love you guys. You're great. So the C6GD instances, which are in those 1U ones, like you can go up to 64 vCPUs, 128 gigs of RAM, and then you got a couple like 2 terabyte NVMe SSDs in there. The 2U ones, you have like Ice Lake processors at 3.5 gigahertz, and then you get like 128 vCPU, 256 gigs of RAM, all the way up to significantly more than that, and then like 4 2 terabyte NVMe drives. So this is the thing that I'm most excited about, and that's local zones. So I think local zones, if you want to see a great example of local zones, look at the Riot Games talk from reInvent last year. They talk about how they were able to deliver sub 35 millisecond latency to the gross majority of their players. So they make a video game called Valorant, which is a first-person shooter video game where latency matters because you know, it's called the who shot first problem, and it's not about Han from Star Wars, but you know, it was honestly, frankly, solved by Tribes 2, if anyone remembers that game, back in 1998. And they use a really cool algorithm called Kalman filters to figure out what the moving average of the players are. And then we can get into that later if anybody's interested. But this Riot Games, what they did is they were able to go and provision in colos with Outpost, in local zones, and in all the regular AWS regions, all of the servers that they needed to host their game. And to be able to deliver that sub 35 millisecond latency to all of the players that are playing Valorant. And they can then do partitions so that they make sure the players that are generally near each other can all play and get routed there. It's a very, very good talk. It's very interesting. And they also talk about how they prefer this sort of flat network. And Netflix has talked about this as well, that CloudWAN offers you. So how does it work? It's really, really easy to enable these. What I've been trying to do every time I talk about this is I'll change it to the city that I'm in, but you don't really need a local zone in SF because you already have a region, but whatever. So you know, you can go and you can provision this, and I was able to get single-digit millisecond latency when I was in Atlanta to this local zone. When I say single-digit, I mean 2 milliseconds. So that was the latency that I was able to get round-trip time, which is pretty awesome. And it's quite easy to enable these. You can do it with an API call, or you can do it in the console, and then you're off to the races. You can provision anything. You can provision EC2, EBS, FSX, load balancers, EMR, Elasticache, RDS, and other services are coming more and more to that area. Now we have Wavelink Zones. So how many people have 5G? How many people have 5G ultra wideband? It's nice, right, when you get the like 2.5 gigabit per second connection over Wi-Fi. Now, how many people are on Verizon and have 5G ultra wideband, and then every time it says the little UW in the top right, it turns out you can't actually route to anything? Just me? Okay. Verizon got to fix that. Because when they first launched, it was amazing, right? Like you get super fast internet, and now I guess everyone's on it, and it just doesn't really work. But regular old 5G can do some pretty cool stuff. Wavelink zones let you, again, provision a lot of infrastructure right into that 5G zone. And these are partnered with telecoms. So these are, like, if you've seen some of these larger cell towers that have all the little modems around them, like the compute for these is often located like right by those towers, like within walking distance almost. Not always, but that's the general goal. So let's say you have an ad network that's bidding on ad placement for different mobile users. You can deploy that to a Wavelink zone. And the way to set this up is you create something called a carrier gateway. The carrier gateway lets you route your traffic through the Wavelink zones. And I tested this when I was in New York. And I was able to get 1 millisecond latency from my EC2 instance that I provisioned in the Wavelink zone to my cell phone. And then everyone in Javits Center started overloading the network, and that was no longer the case. But at 6 in the morning, it happened, 1 millisecond, right? So if you're having a mobile game, if you have an ad network or something else that's latency sensitive, this could be a great place to provision that. It does come at a little bit of a premium. It's like a 20% premium over normal EC2 pricing, but you know, that's what AWS funding requests are for. Now we get into more of the compute side. We have Lambda Edge. I think Lambda Edge is very, very powerful. It's getting more powerful all the time. This will deploy your Lambda functions to in Python, or for shame JavaScript, to any edge location. And it's not really all of the edge locations. It's mostly those 13 regional edge caches that exist, but it gets them pretty darn close to your customers. And you can do things like rewrite security headers, or you can determine whether or not you need to fetch on the origin, or you can do some transform of the origin content, and you can set different behaviors or authentication things. You can do whatever you want to do in code, and you can even access the body of the request under a certain size. Something that people haven't really used. I think Lambda Edge is quite well used now. Anybody not heard of Lambda Edge yet until just now? So Lambda Edge is pretty well saturated. How about Cloudfront Functions? Who's heard of Cloudfront Functions? OK, for the purposes of the video, no one in this audience raised their hand. Just pretend. So Cloudfront Functions run on V8 isolates. Now, these have to execute quite quickly, and they have to be written in JavaScript because we made poor decisions as a society, and we've built our entire global economy on JavaScript. I have no idea why. But these V8 isolates, they can go and they can run at any of these edge locations, and they instantiate immediately because it's already in a V8 warmed up isolate, and they're quite powerful. Now, here's my brief interlude. Conclusion, we'll say. I think the future of the cloud is actually at the edge. So data is hard to solve at the edge, right? Because that takes space. Data is, you can almost make an abstraction layer or a mathematical equation over the amount of time in compute and real estate and power that's required in order to get data to the right place. But as consumers, we've become quite spoiled, right? We want our data, we want it now. We don't want to wait. If a page takes more than a second to load, how many of you go to another tab? OK, it's just me. I have mad ADD. So being able to get your compute and your data closer to your consumers lets you compete better. It lets you deliver better experiences. And it's also a mutually beneficial relationship, because as you move closer and closer to the edge and get closer and closer to your consumers, the cost of routing this information goes down. You have to deal with fewer peers. You have to deal with fewer hops. So, AWS has made significant strides in the edge, but if we're honest about it, they're behind. So look at companies like Cloudflare. Look at what they're doing with the edge. They're trying to build like an S3 edge or a SQL edge. Look at companies like Dino. And the way that they're building out this ability to deploy any form of compute to the edge. There's a lot of very interesting stuff happening here, and whichever cloud provider is able to go and solve this edge compute problem, and I'm not talking like edge compute like the computer under your desk. That's not what we're talking about. We're talking about being able to use the same control plane across regions, availability zones, and the edge, whether that edge is a data center that's operated by someone other than AWS or a data center that you've spun up for your own company. And being able to use that same control plane across everything, whoever is able to solve that first is going to win the cloud wars. So that's my prediction. Full disclosure, I've been wrong a lot. So I wanted to say thanks so much for coming and listening to me rant a little bit today. I'm a huge fan of AWS. I would be remiss if I did not mention my company, Calent. So Calent, what we're a group of passionate technologists who are helping companies build the next generation of cloud infrastructure. We found out that we all have ADD and we don't like working on one product for the rest of our lives, so we became consultants so we could work on a bunch of different products. We're an AWS Premier partner, and we always love hearing about what people are doing and what they're building and trying to contribute to that. Now, why should you take anything that I say seriously? I've been doing this for a little while. I got my start in programming and video games, and then I found out the stuff that I was doing. Anybody ever heard of RuneScape? Okay. So for a little while, I ran like a botting empire on RuneScape. I was 11, and it turns out that's super illegal. So I repurposed my malicious behavior, and I became a physicist for a little while, and I worked at NASA, which is actually just over here at Moffett Field, and I had a great time there until I found out how much the computer science interns were making, which was like $9 grand a month. Meanwhile, us lowly physicists, we were making like $4,500 a month. And so I went on LinkedIn, which was new at the time, and I changed my title from physicist to software engineer. And lo and behold, my salary doubled. And then I went to MongoDB, and I worked at SpaceX for a while, and AWS and Facebook, and now I'm at Calent. And across all of this, I've started investing in a lot of startups and looking at how they're building their infrastructure. And there's so much stuff happening behind the scenes right now in terms of how the global infrastructure is evolving that it behooves everyone here to kind of keep pace, understand what's going on. Please follow me on Twitter for the internet points. And if you want to see more rants and hot takes about AWS technology, like why when you say the name Code Whisper, you can only whisper it, you can't ever say it out loud. That's where you can find out. Thank you so much for coming, and thank you again to the organizers for such a wonderful day, and look forward to hearing some closing notes now. This is my first ever talk without a live demo. I don't know what's next. Are there any questions or anything like that?
Yeah,
Go for it.
I believe you are the expert for the AWS infrastructure. I'm curious, do you know is any special cloud, designed and to serve DoD or military?
Well, the snipers are here, so I'm not allowed to talk about that. They'll use their thermal imaging, shoot me through the curtains here. No, I think GovCloud is one thing. GovCloud, when we were at SpaceX, we ran a number of different workloads in GovCloud. There's a thing called ITAR, which is the International Traffic and Arms Reduction Treaty, whatever. It's some nonsense. Can I swear? Is the video stopped recording? Yeah. It's basically a way to stop the proliferation of nuclear arms and rocket technology, or not rocket technology, sorry, intercontinental ballistic missile technology, which happens to be the same thing as rocket technology. And it's a bullshit law that doesn't really matter anymore, but because Congress moves at a completely glacial pace, it's impossible to ever get this thing updated, so only US citizens are allowed to work on rocket stuff. And it's just complete nonsense, and this thing, I know people who have moved to DC to lobby against this and figure out a way to change it, but then you got Boeing and Lockheed and all these other people who don't want it to change, and they have boatloads of money. I can't really diss Boeing too much, despite the fact that they've spent billions of dollars of our taxpayer money recently trying to launch SLS. Huge disaster, great job. When I was at NASA, almost 15 years ago, I worked on the Orion program, and it still hasn't launched, okay? That's how bad this is. Let's not rant. What was your question? Oh, secure. So security-wise, yeah, you have something called Nitro. So there's a couple different things within the Nitro system that allow you to go and say, I want to run in a secure enclave. I want to be able to have the full power of the instance available to me, but I want to be able to do encrypted compute. All this stuff is enabled by this Nitro card. This is a hardware platform that exists as a top-of-rack switch. It exists as a card within the server, and it exists as a software layer as well.
Good, very good. Actually, the reason I asked, I go for Boeing, I go for Navy.
Sorry.
Yeah, so I just wonder, is the AWS, direct kind of the technology for JC2?
Yes.
JC2, yeah.
Yeah. No, so if you look at Azure's, again, AWS PR is not allowed to tell me to stop talking right now so I can talk about competitors. Both Google and Azure talk a big game marketing-wise about confidential compute. It's vaporware, it's non-existent. If you go and try and spin it up, it literally doesn't exist. It's just complete marketing fluff. Whereas AWS has an actual secure enclave that you can go and provision things. They have FIPS 140 endpoints. They have all of this capability that is actually real and exists, and you can verify it by just going and using it. It takes 5 minutes. And then you go to Azure and you're like, hey, I want to use a FIPS 140 endpoint, and they're like, here's the documentation, and then you hit it, and it doesn't resolve because there's no IPs and it's not a real host name. Like, it's just complete like marketing fluff, and very few people go and actually verify that it exists or not. So yeah, if I were a government or if I were a government contractor or something, yeah, I'd go all in on AWS for now. Now, if you look long term, I think it is inevitable that Azure wins in some way because they control everything, right? Like they have LinkedIn, which is where developers go to like get jobs. They have GitHub, which is where developers go to deal with code. Like they have TypeScript, and they just have no, like if they don't win, it's their own damn fault. But it's going to take many years. So like right now, I would bet very strongly on AWS. And AWS has a lot of opportunity to go and disrupt Azure, and Google's off in the different realm, and Oracle's off in a different realm. We don't have, an IBM Cloud isn't real, so.
Thank you.
I'm gonna get canceled on this. Are we donezo? Any other questions?
So the local zones, can you consider that equivalent to like availability zone?
To the what zone?
The local zones. The local
So it's not a full AZ. So that's the thing. Like, you can run a lot of stuff in local zones, and I expect over time more things to be available in local zones. Again, if anybody works at AWS, I have a PFR to make DynamoDB endpoints available in local zones, at least. But there's certain things that need multiple availability zones to work, like Aurora, right? That needs multiple AZs for the storage layer of that to work. Then you have things that don't need multiple AZs, and I expect in the fullness of time, anything that doesn't need multiple AZs is going to move to a local zone and be available there. But yeah, you just treat it basically as another AZ that you deploy to. The same run instances command that you use to launch within one AZ will work just fine in a local zone. There's a little bit of networking nuance, but I mean, that's solved quite quickly. Anything? All righty. Well, thank you all so much for coming, and thanks again to the